Good morning all, I am HEMALATHA, Assistant Professor, PG and Research, Department of Computer Science, St.Joseph College of Arts and Science, Autonomous Cuddalore. In this video, I am going to explain about vector supercomputer. Before that, we have to know Flynn classification. M.J. Flynn proposed a classification for the organization of a computer system by the number of instructions and data items that are manipulated simultaneously. Flynn's classification divides computers into four major groups that are depends on data stream and instruction streams. First type is single instruction stream on single data stream, that is SISD. Next one is single instruction stream on multiple data stream, SIMD. Next one is multiple instruction stream on single data stream, MISD. Last one is multiple instruction stream on multiple data stream, MIMD. In vector supercomputer, execute single instruction on multiple data. In this diagram, instruction and data transfer from mass storage to host computer. Mass storage can hold huge number of data and instructions. Record instructions are transferred to the host computer. Host computer transfer that instruction and data to the main memory. From main memory, the instructions only transferred to the scalar control unit, not data. Scalar control unit received that instruction and decoded it. Then only it can find out whether that instruction is scalar instruction or vector instruction. Scalar instruction in the sense, it's a, for example, if you are going to add A plus B, so addition of two numbers, A hold single value and also B hold single value. That type of instruction is known as instruction execute on single data. That type of instruction is known as scalar instruction. So scalar control unit find out whether that instruction is scalar. That instruction is transferred to the scalar functional pipeline. Scalar functional pipeline received instruction from the scalar control unit. Then it requests data to the main memory for execution. Then main memory, after receiving the request, it sends data to the scalar functional pipelines. After execution, after end of the execution, the result will be stored into the main memory. This is scalar instruction process. Whether the decoded instruction is vector instruction, it means one-dimensional array of instruction. That instruction is transferred to the vector control unit. Then vector control unit send instruction to the each vector functional pipeline. Each vector functional pipeline received instructions. After that, it get data from the vector register or it can get directly from the main memory. It depends on the memory access model. After a data fetch from the register or memory, it execute that instruction and after that it send output to the vector register or it will be directly stored inside the main memory. This is the process of vector supercomputer. So this slide explains the theoretical process of vector supercomputer. A vector computer is built on top of a scalar processor. The vector processor is attached to the scalar processor as an optional feature. Program and data are first loaded into the main memory through a host computer. All instructions are first decoded by the scalar control unit. Then only it can identify whether that instruction is scalar or vector. Then if the decoded instructions are a scalar operations or operator or a program control operations. Program control operations in the sense jump statement, loop, okay, any other program control statements included in this types. It will be directly executed by the scalar processor using the scalar functional pipelines. If the decoded instruction is a vector operation, it will be sent to the vector control unit. Then it will be transferred to the vector functional pipelines. Okay, this control unit will supervise the flow of vector data between main memory and the vector functional pipelines. The vector data flow is considered by the control unit. A number of vector functional pipelines built into a vector processor. There are two types of vector supercomputer model or classified. One is a register to register architecture. Another one is a memory to memory architecture. During the vector operation, each vector functional pipeline get data or instruction from register instead of main memory. That model is known as a register to register architecture. Another one is a memory to memory architecture, means each vector functional pipelines get data directly from the main memory. That architecture is known as memory to memory architecture. Thank you.